Remember how absolute value works? When we have these bars around a number, we want the absolute value of that number. What's the absolute value of -3? 3. What's the absolute value of +3? Also 3. Remember, the absolute value of a positive number is just that number, and the absolute value of a negative number is its opposite, which is positive. So either way, absolute value always comes out positive. So if I wrote the equation, the absolute value of x equals 3, and I say, okay, what could x be? What number can we put inside the absolute value bars and have the absolute value be equal to 3? Well, we've just seen there are two possibilities. It could be -3 or it could be +3. So that equation has two solutions, x equals 3 or -3. What about if the absolute value of x equals 17? What can x be? Did you say 17 or -17? If so, you're right. What about the equation absolute value of x equals -4? What can x be there? Well, actually, x can't be anything because no matter what x is, when you take the absolute value, it can never come out negative. It can never equal -4 because absolute value is always positive. Well, almost always. Could the absolute value of x equal 0? Well, there's one way that could happen, and that's if x is 0. So notice the possibilities here. For the absolute value to equal a positive number, there's two solutions. For the absolute value to equal a negative number, there's no solution. That just can't happen. For the absolute value to equal 0, which is kind of right in between the positives and negatives, there's one solution. Now, what if it's not just x, but something more complicated inside those absolute value bars? What if we have the absolute value of some expression involving x? Well, the rule is when the absolute value of some expression equals some number, that breaks down into two possibilities. The expression can equal that number, or the expression can equal negative that number. It can equal the positive or the negative. That's assuming the number was positive to begin with. If the absolute value was supposed to be equal to a negative number, then there would be no solution. We could right away say, can't happen, no solution. So let's try this. Remember, here's how we deal with absolute value equations. If it says absolute value of something equals some positive number, we solve by turning it into two separate equations without the absolute value bars and solving each one of those. If it says absolute value of something equals a negative number, we can just right away say no solutions, can't be negative. Absolute value of x plus 1 equals 7. So remember, we immediately break that up into two separate equations. What are those two equations? Well, one of them is x plus 1 equals 7, exactly like what you see here, but without the absolute value bars. And the other one is x plus 1 equals -7. Because if it was equal to -7, then when we took the absolute value, we'd get 7. Now we solve each one of these by subtracting 1 on both sides. X equals 6, or x equals -8. So those are the two solutions to this equation. Notice if I plug 6 in, 6 plus 1 is 7, and the absolute value of 7 is 7. If I plug -8 in for x, -8 plus 1 would be -7 inside the absolute value bars, and then the absolute value of -7 is 7. What about this one? Absolute value of 3x minus 2 equals 17. So what are the two separate equations that this breaks up into? 3x minus 2 equals 17, just like this without the bars, or 3x minus 2 equals -17. And then we solve each one of these. Add 2 to both sides and divide both sides by 3. Over here, we get x equals 19 over 3, 19 thirds. And over here, we get x equals -5. So there would be the 2 solutions to that equation. By the way, remember absolute value bars sort of act as grouping symbols. You're taking the absolute value of the final number that evaluates to. So you can't sort of break it up into, okay, we got the absolute value of one thing plus the absolute value of another thing. It doesn't work that way. How about this? Absolute value of x minus 4 equals -3. Do you see what's going on here? What do we do with this? No solution. Absolute value can't be negative. As soon as you saw absolute value of an expression equal to a negative number, you right away say, can't happen, no solution. Now what about this one? The absolute value of x minus 11 equals 5. This is a little different from any of the other examples we've seen so far because the absolute value is not by itself on one side of the equation. So before we do anything else, we need to get it so that the absolute value is by itself on one side of the equation. How can we do that? Well, we can undo the minus 11 by adding plus 11 to both sides. Then we would have the absolute value of x equals 16. And what 2 separate possibilities does that break up into? X equals 16 or x equals -16. And so those are the 2 solutions. Now, before we leave off talking about absolute value, here's a little note about how to think about absolute value. One way to think of it is it can represent distance on the number line. You can think of the absolute value of a number as telling you how far that number is from 0 without telling you which direction. So if the absolute value of a number is 3, it means that that number is 3 units away from 0, one way or the other. You could be 3 units away to the right, which would put you at +3, or you could be 3 units away to the left, which would put you at -3. But they're both 3 spaces from 0 in one direction or the other. And then if we were talking about not just how far a number was from 0, but how far one number was from another, how far apart 2 numbers are, if we didn't know ahead of time which one was bigger and which one was smaller. Absolute value can also be used for that. The absolute value of something minus something else tells you how far apart those 2 things are. If you knew which one was bigger, you could just take the bigger one minus the smaller one, and that would tell you how far apart they are. But if you didn't know ahead of time which one was bigger and which one was smaller, you wouldn't know what order to do the subtraction in. But by putting absolute value bars around the difference, doesn't matter. So the absolute value of x minus 6 would represent the distance between x and 6, how far x is from 6. Suppose that's 2. Suppose the absolute value of x minus 6 is 2. That means that the distance between x and 6 is 2 units. So x is 2 units away from 6 in one direction or the other. Here's 6. What are the numbers that are 2 units away from 6? Well, there's 4 and there's 8. So those are the 2 possibilities for x. And if we solve that equation the way we've been talking about, break it up into, okay, x minus 6 equals 2 or x minus 6 equals -2, those are the solutions we would get. X would be either 8 or 4.